Yes, thank you very much, Raymond. And as Scott mentioned, I will talk not exactly about VTune this time. Actually, if we need more sessions, we can we can do some deep dive into VTune. But today I will talk mostly about application performance snapshot.
I'm gonna bring it up.
That's yeah, and let me talk. What is the tool? Why it can be useful as we think, and the tool actually right now is in beta, and that's why we're also collecting feedback, and we'll appreciate your feedback, what metrics might be useful, uh, the representation way that we have, and stuff. So let me start, and uh, let me start with this slide that actually says that uh, the performance of a modern HPC application is a pretty complex thing, right? That consists from different aspects, uh, starting from internode, like for example, for performance with message passing, right? And the problems that might be specifically for message passing, and especially it's increasing when we have big scale, right? Uh, this list might be not full, of course, of particular problems in particular aspects. This is just to show that the performance is not a simple thing, right, for HPC application. So we have inner node performance aspects. Like for example, memory hierarchy becomes more complex. For example, for Xeon Phi, so multi-channel DRAM was introduced, but actually, as also Scott mentioned, like for example, in flat mode, you might need to make a decision what particular data objects should be placed in MC-DRAM if they are not, if the working set doesn't suit the 16 gigabytes of MC-DRAM, right? So we are going to have persistent memory with 3D crosspoint. We have more and more cores and pure MPI applications with this big number of cores that we have per node might have problems. So that's why I think more and more applications moving to hybrid, some hybrid MPI plus something approach, like for example MPI plus OpenMP, that allows to utilize cores inside rank and decrease message passing inside the node, right? And also we have vectors that are also increasing. Like for example, in KNL or like Skylake server, we have AVX 512. And again, to efficiently vectorize, you need to understand about like problems that, for example, compiler might experience not vectorizing the code and stuff. So the landscape is pretty complex, and fortunately, we have at Intel, so we have Parallel Studio that with like several tools that covers particular aspects, like for example, Intel trace analyzer and collector specializes on particularly internode aspect of performance, right, with message passing efficiency, showing message passing efficiency. We have Intel Advisor that particularly focuses on vectorization efficiency, and not only, so some like threading design might be also actually worked out with Advisor, right? And we have a Intel VTune amplifier that covers threading, that covers memory, some elements of I/O analysis, and microarchitectural analysis efficiency, microarchitectural efficiency analysis, and stuff. Why we don't have like a unified tool for these details, like for such detailed analysis. There might be like some historical reasons. There might be some, I don't know, other reasons, but this is the fact. So, for example, right now we have at least 3 tools that are specialized on particular aspects of performance. Okay, and but before we dive to a particular tool, first we might want to assess, so what actually what potential I have in performance tuning. So do I have like bottlenecks, serious bottlenecks, or in particular aspects? Which tool should I use, right? If I have these bottlenecks, what to use on big scale? Because it's not a secret that even Intel Trace Analyzer and Collector will not work on big scale. I'm not talking about VTune and Advisor, but even for iTech, um, it might be a problem. And just on KNL node, we might end up with more than 100 ranks. Like on KNL cluster, we might end up with more than 1,000 rank on just 8 nodes, utilizing just, for example, 2 hyperthreads per physical core, right? So in terms of ranks, scale is increasing, might increase. And for example, if I'm experimenting with some environmental settings or like some small incremental code changes, I might want just to see to quickly look how these particular changes impacting like different aspects of performance, right? And that's why we decided uh, to try to bring up a application performance snapshot for particular for HPC application performance exploration. So to be like in more details, application performance snapshot will give you high-level overview of application performance regarding like several important aspects, and we'll try to identify primary optimization areas. The logic might be simple, but still it might be useful to have on the one page. When we were designing it, the first thing that was put into design was ease of use, and like just knowing about like concerns that, for example, we have for VTune that for a long time that it's not very simple, to extract some particular judgment from VTune views because they might be not very simple to comprehend. We have overview metrics on HTML page or on the command line report, but we also have a set of detailed reports particularly for MPI efficiency. One thing is that we want to have this tool working on every scale. Currently in beta, probably we didn't put a lot of attention to this, and we might have particular problems, but we're working on this. And by gold release, that should be somewhere in July, August, I think that the majority of problems will be fixed for big scale. And application performance snapshot right now is a part of Parallel Studio, but also one good news, I think, is that it's available for separate free download from performance snapshot page on Intel Developer Zone site. And the package is approximately 100 megabytes, so you can just download it, unzip it, and use without requirement to set the driver and stuff. So it should just work out of the box in the majority of cases. Okay, so this is just an example of simple of a HTML, typical HTML application performance snapshot report. We will like look at aspects in more details, but what we can see here is and yes, and this report is for how it looks like for actually for kernel. For big cores, for Xeons, it's a bit richer in terms of hardware metrics, because it's not a secret that on kernel we are missing some metrics in comparison with big cores, and that's why the analysis probably based on PMU events is not as good as for big cores. But what we can see is like elapsed time of the application. We see the cycles per instruction, like average by ranks, and in terms of like we also see minimum and maximum, and the area. Yeah, and let me like go further, and we will see like particular areas of this report. What metrics show and how they are collected. Yeah, and before this, how to use actually APS. So first, we need just to unzip the package if it's like from scratch, right? Source variables. Then put aps.sh between like MPI launcher or job launcher and application with arguments, and like run this with job scheduler or interactively, and then like by default APS will create a folder. It creates a folder, I think, in yeah, you can actually from in the directory where it was launched, but you can also specify the directory through a special option like -r the path to directory. And I think that it's important when you run it through job scheduler. Then
Dmitry,
after,
can I ask a
yes.
question?
Uh-huh.
So the only difference for our users would be on the Cray system we use AP run, and they just have to add the aps.sh, shell the script in that AP run, MPI options, APS sh, and then the applications. Is that how it would work?
Right. That's I needed also to substitute probably MPI run with just general MPI launcher or job launcher, right? But yes, this is a good comment, Scott. And you just need to put aps.sh in the middle of AP run and application to launch. Yeah, and the MPI application. That's
so for most people, this is just one small change to their run script, and that's it.
Right.
So
and then when the
I'll just mention. So we're going to work with Mike to make a common installation of this, so that everyone doesn't have to download their own copy of it. And then
folks, this is Mike DeMello. I've actually tested this out on Theta, both with serial codes as well as with MPI codes, and it works. So we have done some testing of this already on Theta.
Yeah, right. And we need to pay attention that the package that Michael tested is a bit tweaked to work with Cray MPI, right? So until we have these with patches incorporated into APS official build, it's better to use the package that Michael is going to deploy on Theta, right, Michael?
Sure, absolutely, because there's There's one odd interaction with the job scheduler, but there's a simple workaround. So yeah, so just follow what Dmitry just said. We'll use the local copy, so you don't have to download and install your own.
Okay, then after the run, the result directory will be created, and you need to generate a report with the dash report command. And after that, you will see the command line report that will be generated on the screen, and also HTML report will be generated, and you can, for example, bring it up if you have GUI context. Mostly they are like mimicking the same. They are the same in terms of content, but of course with HTML report, it's simpler, for example, to see metric descriptions, to see issue descriptions as tooltips, and so on. And if you want to generate detailed report for MPI statistics, then there is a different command, APS report.sh, that also has dash help. And after you see dash help, you can choose a particular detailed report. And we will look at several examples of this detailed report for MPI statistics. All this work with Cray MPI, and where some metrics are not available, I will say about this explicitly. Okay, so there is a summary zone in HTML report, and also there is, I think that there is no such a zone in command line, but yeah, this is mostly in the HTML report. So here we try to define some, some target numbers for threshold or thresholds for particular performance numbers, for performance metrics, and graphically, for example, express the impact of particular performance aspect to the performance, to the overall performance. Of course, sometimes it's difficult to to compare apples with oranges, because metrics sometimes has, some of them are wall time, some of them are in for example, pipeline slots, execution pipeline slots. But anyway, we tried with these red bars to probably to draw your attention to a particular aspect. And then so what aspects we have, like MPI focused aspect? It has several metrics. So one is MPI time. Actually, this is a average MPI time per rank, and we're expressing it not just in seconds, but also as a percent of elapsed time. And of course, if your application, for example, has MPI communications overlapped with, if you use hybrid application, for example, MPI plus OpenMP, and your communication is overlapped with computations in other threads, sometimes probably this percentage of elapsed time might be not, might be interpreted not in the way that that it should be, but like the big bunch of applications doing MPI communications in serial part of code, right? And in this case, the percentage of elapsed time will just show you the impact of communications on elapsed time. So there might be cases when they will not be like the exact elapsed time impact. Again, so if your communication overlapping with computations in different threads, well, we're thinking how to express this, because we have this information for MPI plus OpenMP, but now the metrics is simpler. So this is just average of MPI time per rank and the percent of elapsed time. We also have MPI imbalance time, and this is the time that MPI spends in Progress Engine. But this metric right now is available only for Intel MPI. So for Cray MPI, you will have is a 0 or NA, something like that. Because right now it's a proprietary implementation of Intel MPI. And we also show top 5 MPI functions, like how they contribute to MPI time. Like some customers found this useful to have top functions write on HTML or command line report, because it might in some sense show you the nature of the MPI time, so where it actually is spent. Okay, let us move on. So for OpenMP, currently we have just OpenMP imbalance metric, and again this is a average per rank. OpenMP imbalance metrics is available for Intel OpenMP implementation, but I think that this is the Intel OpenMP is the major, I think, runtime that is used right on Theta. So, as I assume, and this is based on some proprietary instrumentation of Intel OpenMP runtime library. We know about OpenMP standards edition of OMPT interface and looking at this, but currently it's available for Intel MPI.
That is exactly what I was just going to ask you.
I can imagine that that might be interested in having these metrics for GNU, for example, OpenMP or other implementations, right? So what implementation are you interested at? Sorry.
No, I was mainly thinking just from the standards standpoint of whether you were, at what point you were involved with the, the profiling standard in OpenMP.
Mm-hmm.
So I'm glad to see you're thinking about it already.
Yes, yeah. Frankly speaking, we were not very active in shaping OMPT standard, but currently we're looking at this direction. Yeah, and of course, it's better to be based on standard than on proprietary instrumentation, especially taking into account that this OMPT implementation, I think, will be enabled in Intel OpenMP quite soon, right? So yeah, I agree. The imbalance time is pretty precise because currently with our proprietary implementation, like OpenMP runtime library calculates this for us, and actually this is the time imbalance time that is normalized by number of threads. So this is like a elapsed time like a wall time impact of imbalance on the application. So this is not just the cumulative time by all threads, but normalized. The next metric is our attempt, to build some insight to vectorization efficiency based on performance counters that KNL has for big cores. Sorry. Yeah, we have just a couple of events there that allows us, to show like vectorized portion versus color portion of CMD instructions. But this will not show you for example, what instruction set did you use? Like, for example, if you use AVX2 instruction set and use just a half of vector capacity, it will not reflect it here. So this is just a very, I think, high-level metrics, and it doesn't take into account masking, of course, right? So this is just probably vector how it's vectorized from very overview like point of view. And like for memory, we have also several, for memory efficiency, we have several metrics. Backend stalls, like for big cores, we have a quite good metric, memory stalls, that allows you to actually to learn how many like potential execution pipeline slots of your processor, of your cores are just lost because you're like fetching data from different hierarchy of memory subsystem. But on kernel we don't have memory stalls metric. We have just backend stalls metric that actually includes both memory stalls and, for example, stalls in cores. If you have like conflicts by execution resources, that's why backend stalls not directly like reflects the problems with memory, but it just includes them. But for example, if you're experimenting with, I don't know, with some cache blocking, or you're trying to make your algorithm more cache friendly, then still looking at backend stalls might be a useful thing, because like the less memory stalls you have, so the less backend stalls you will have eventually. So like relatively it will show you if you are moving to right direction with particular changes, right? And under backend stalls we have two metrics, L2 hit bound and L2 miss bound. So L2 hit bound reflects the number of L2 memory requests that were saturated in L2, and with like multiplying this number to like average cost of this hit. So we're like showing the percent of like cycles that were occupied with this. And L2 misbound means that, yeah, these metrics, again, so very rough. It includes the number of cache misses multiplied by like some average cost. But again, so yeah, we understand that average cost might vary. Like the cost may vary, but we have some numbers that are, we think, practical, and we're multiplying on this like average cost. So we're expressing again the numbers in cycles, right? So, but we of course need to be careful here, that because, for example, it's not a rare situation then like the hardware prefetcher intensively working can actually impact like memory bandwidth, right? And you will have like you will be like memory bound and even backend bound, just not because of L2 like misses, right? But because of L2 requests. Oh, because of L2 requests that are actually activated by hardware prefetcher. So this again, so we are thinking on so right now these statistics work upon perf. Probably I think that the majority of audience knows that that perf is like built into like Linux kernel and Linux distributions, like capability to collect hardware events. But usually by default, ability to collect uncore counters that allows us, for example, to show MC-DRAM and DRAM memory bandwidth is usually closed with the performant per node settings. But you know that currently we're thinking, and this is in the progress, like for example, if VTune SEP driver, proprietary driver, is installed on the system, and yeah, usually for big supercomputer centers, I think it might be the case, right, where VTune is enabled. So then APS, I think, in very short future will be able also to collect uncore counters and show the average MCDRAM and DRAM bandwidth. But now it's not available. But we think that we will be able to do this. And then, in this case, currently it might be, a bit tricky to interpret, for example, backend stalls with like not having memory bandwidth information. Okay, and also we have a couple of metrics. Let me go back a bit to the report. So we have a couple of metrics on memory footprint, but actually this is probably it's not very useful right now, but this is like virtual memory peak. Hence, we already had feedback that it might be not very useful. Resident memory might be, like for example, peak might be more in interest, and I think that it will be enriched. These statistics will be enriched with resident memory peak. But since we with APS we don't collect overtime statistics, so we don't have overtime trace. We just have aggregated numbers. That's why we can show only like the peak for memory footprint. Sorry. Any questions? Okay.
Actually, it's going back to the information reported about threading. Dave has a question about that. Dave, are you on?
Yeah, I just had to turn on my microphone. So my question, was, the reports look great for OpenMP. How about other threading frameworks, like especially TBB? Does this give similar types of results? Thanks.
Yeah, I guess that's sort of another way of asking, does it extend to P-threads in general?
Right. So currently such statistics of threading efficiency is not available for other threading models like threading libraries like TBB or P-threads. And but because you know that I think that for OpenMP it's so with the collection. First of all, we need to say that with the APS collection sampling, so we do just counting mode, so we don't have execution context. So that's why it's not for us possible to determine if the samples are in runtime, either pthread or TBB, or in user code. This is done for the sake of scalability of the tool, because we can imagine that on big scale, so the traces might be huge if we collect sampling with execution context. So that's why this particular tool doesn't have these statistics. For OpenMP module, it's since it's like it has fork join nature mostly, right? I mean, the majority of cases written on OpenMP. So sometimes it's pretty simple to instrument and collect. Actually, instrument not per thread, instrument, for example, in master thread. And this is important because not to bring overhead. And calculate, like, for example, serial time and imbalance. For TBB and OpenMP, where, like, in general case, the the threading is not as well structured as like ForgeRoot and OpenMP, it's trickier to judge on a particular threading efficiency aspects. So that's why currently we don't provide insight into parallel efficiency of other parallel runtimes. In VTune, actually we do this because VTune collects sampling, and with sampling we can classify samples like situated in particular runtime functions, and we can recognize that, for example, we have an imbalance, or we have a scheduling overhead, or we have lock contentions, right? In VTune it's available, but not in APS currently. Did I answer the question? Sorry. Okay, I think that. Yeah, and let me just and for okay, I talked about memory footprint. For IO bound, I think that the metric is also pretty primitive. So we just use /prots /stat like information that is in /prots like file system folder, right? Structure, and it allows us to calculate time IO, like that CPU's lost because of waiting on IO, and with the assumption that, for example, ranks are pinned, so we can actually, yeah, with this assumption we can attach this information to ranks and show this by, for example, the IO by ranks, and the judge on how the application is IO bound. And actually, I have a pretty short demo. Probably I will show how reports are look like on in the demo. But this is just a screenshot of a part of a report that APS shows. Actually, it shows you the metrics, and if the metrics broke thresholds, so we're showing particular like issue descriptions that might help. But you can easily just filter out the descriptions with grep command, for example, and just avoid them and have a good structured report without these descriptions. So I think that, yeah, descriptions might be helpful at the beginning, but then you might want to just eliminate them, and it should be done pretty simply, just gripping out the rows with the vertical line symbol. And for advanced MPI statistics that are also available for Cray MPI, so we can show several tables, like, for example, MPI time per rank with an imbalance, but imbalance again only for Intel MPI. And probably what is more interested, we can show like message size for MPI messages, and also, like, for example, data transfers per rank to rank communication. Yeah, in megabytes, and the percent from the overall, I think, data transfers. And there are also a couple of probably more detailed reports on MPI specific statistics. That's probably all about APS, but let me also, yeah, just say one more time that APS probably can be mostly treated as a like entry-level tool. From one point of view, that will direct you to probably more detailed tools to understand inefficiencies in particular aspects. Like, for example, memory, the tool will direct you to VTune amplifier, or like, for example, trading MPI problems like ITAC, advisor, vectorization to advisor. Probably will. I have several foils about like these tools I just listed, but probably let me probably skip them. And Raymond, I actually have a live demo. If we have 5 minutes, I can show it if it's interesting.
Yeah, we have 5 minutes for that. Yeah, go right ahead.
Yeah, or we can, or if there are other questions, I'm ready to answer. And if you have time, so we can conduct demo, or we can just conduct demo. Just your choice, I think.
Does anyone have any questions before we move to a demo? Okay.
Oh yeah, and let me also say that in the pipeline of feature requests that we have and seriously considering to implement is first, ability to pause resume collection with, for example, MPIP control or ITT pause resume. So right now it's not available, but for example, if you want to exclude initialization or finalization, you might need to have such a such control, right? And also, so currently we are working on some startup overhead that we have for big number of ranks on kernels. Like if you have the number of ranks, I don't know, more than 100, for example, so then you might observe some startup overhead that collection APS will introduce, but it will be shortly fixed, I think. And and also a couple of other things connected with the tool scalability. Okay, so this is the package. Actually, I will just untar the package. So from the beginning. By the way, do you see my my console?
We're just seeing a gray screen right now.
Oh, sorry.
It looks like the very edge of some windows is showing.
Oh, I see. Yeah, probably I just need to share the whole screen, right? Hello?
Yes. We're just seeing you right now.
I think that I can share the whole screen and can switch to my console.
Oh yeah. Okay. Now we're seeing. Yeah, we're seeing a large blue window now.
Okay, this is just a file manager that allows us to, in some graphical representation, to see what happens in directories. So here, like for example, I have an archive of APS. I just unzipped it, and you can see several like one directory and several files there. So and
so
APS vars, yeah.
So the run is wrapped by APS.sh.
Yeah, I will show you. So this is just a tool. Yeah, this is the directory for the tool. On the right side, in the directory, you will have just README, the script with the source and variables, and the run script. And on the left side, I have a directory with the NPB multi-zone benchmark. Do you see it? Right? And I prepared so this is, by the way, this is the Broadwell machine with 44 two socket with 44 physical cores, 22 per socket. Sorry. And 88 logical cores. So, and I prepared 2 BT like NPB multi-zone benchmarks with 22 ranks and with 4 ranks. So let me run, and I have a run script. In this script, I just set in like number of OpenMP threads, and then I have a MPI run since I use Intel MPI with the binary and APS in the middle between the launcher and the binary. So is it understandable? So yes, I need to do this.
Yeah. So on our system, we would substitute app run for MPI run, but still use the APS.sh, right, Mike?
Mm-hmm.
Yeah.
Right. So currently, yeah, we have 22, like for example, 22 MPI ranks and 4 threads per rank. So let us launch it and see what will happen. I think it should be pretty fast. Okay. So here we can see the actually, yeah, to help with report generation, APS will just will like generate a tip that you can just copy and paste to generate the report. So I can just copy this and paste, and here we are. So I have the report, and just let me to go to GUI view because it might be more I don't know, better. So in here, what we can see, yeah, we can see like MPI time, right? Like as a fraction of like about 30% of the wall time, and we see, yeah, with memory it's more or less like good because yeah, there are memory stalls, like some stalls in cache. DRAM traffic is pretty small, right? Like opening pin balance is small, and regarding like FPU, so yes, we can see that the application is not well vectorized, and it uses not AVX2 instruction set, but like some older instruction set SSE4. So here we have opportunity, for example, to recompile it with like to use more vector capacity. Okay, let me then just show you a like different combination of threads and ranks, and we will see what will happen. Then I have, for example, four ranks and 22 threads per rank, right? I can just, yeah, if I'm not pointing the result directory, then it will be just generate a result directory with the data, with the date inside. So it's stat and the current date. Okay, so we need to generate report again with the current data, and yeah, let me again. So I have one more HTML file. Let me go to GUI and show you the HTML file. Show it up. So what we can see, actually the elapsed time right now worse, yeah. The MPI time is like 20%, so it's less. So we have less MPI communication, and that's probably expected, right? Because we have less ranks. But we can see that OpenMP imbalance right now is higher, and this is connected with the fact that we have more threads per rank, and we can see that there is imbalance here. we also can see that like in terms of like memory, it becomes a bit worse. And actually, yeah, vector metrics are the same because we don't we didn't change anything regarding vectorization. And the IO bound and memory footprint, I think it's like, I don't know, it's just no any flex here. So the like what we see here in this in this picture, so then the more threads per barrier brought us a bit more like open MP imbalance, and even with less MPI time per MPI time, since we used 4 ranks, so we ended up with less open MP efficiency here. So that's how I for example can very quickly interpret the data. To have more like deeper analysis, so we need, for example, VTune to see what happened with open MP imbalance. But let me say that I use all hyperthreading here. So probably if we, like, for example, switch this off, it might like we might have different numbers, right? We can experiment with this right now if you want, or we can just, or probably the time is almost over. So if we have more questions, so we can focus on questions.
I think you might have a few slides left in your presentation as well.
So by the way, how much time do we have?
Well, officially, it actually ends now, but we can go a little bit over, would be okay. But we should try to wrap it up in the next 10 minutes.
Yeah, okay. I had some slides about like VTune tools, just very, brief overview.
I did have one question, if I may. So yes. I couldn't see too well some of the demo, but so if we're looking at this on KNL, is this going to show us something about the high bandwidth memory utilization?
So currently, yeah, let me. So yeah, currently you will not be able to see this, but right now we are working on enabling APS working with SEP driver if SEP driver is available. I mean VTune proprietary driver, and in this case we will be able to collect encore events and show numbers of average MC DRAM and DRAM bandwidth. But this is in works, and in the current version it's not available. But I will capture the interest for these metrics.
Thank you.
And actually, I think that right now we have an event that will allow you to see hardware prefetcher activity. So L2 requests, put requests can be like divided to L2 misses, and hardware prefetcher requests. And I think that this also will show up here together with MC DRAM and DRAM bandwidth when we have this working upon driver that allows us to do encore event collection.
Dmitry, are there any issues using this with statically linked binaries, or do they have to be dynamically linked?
Oh, yeah, that's a very good comment. So we have two types of collection in APS. So one is like MPI statistics and OpenMP statistics. They are based on tracing, And for this, we need actually the tool is preloading like collector binary. And for statically linked applications, this is not available, and that's why these statistics will not be collected, I think. So the preload will just not work, and we will not be able to collect the statistics. PMU-based statistics and statistics based on /prods like infrastructure, for example, FPU or memory footprint, memory stalls or memory footprint or I/O, they will be available. This is a very good question. And as for VTune, so we recommend to have insight. We recommend to runtimes. We recommend to switch on dynamic linking. Yeah, that's important.
So Dmitry, in general, are the statistics collected by time sampling or other methods or both?
So here it's just counting mode. And this means that we actually would like the registers that are collecting PMU events, so they are just incrementing particular events.
The hardware counters.
Yeah, the hardware counters. So we don't have any execution context or timestamps to do overtime. So here just pure counting. And again, so this is for the sake of scalability. So the traces are small. And for example, when you collect on like a big number of nodes and on big number of ranks, right? So the trace size should be small and post-processing time should be also like small. If we do overtime or if we do sampling with execution context as we do in VTune, then like the samples with timestamps or IP or instruction pointer will increase trace size and the post-processing time. So we try to to keep AP as a light tool, and still we just to save the room for detailed tools, like VTune or iTech or Advisor, to go deeper to particular performance aspects. So that's.
There was also a question on the chat from someone asking about support for Xeon Platinum CPU.
Oh, Xeon Platinum. So this is Skylake server, right?
I don't know. I'm just repeating the question.
Right,
yeah,
right. I think that
Ken, can you clarify? Ken was the one who asked the question.
Right.
Okay. Hello.
So this is Skylake server that is under NDA right now, right?
We can hear you, Ken, faintly.
Okay. I just want to testing about the Xeon Premium CPU, but I'm using the VTune 2017. It gave me the message that it does not support that CPU yet. So right. I just want to ask about that.
Yes, you need to actually to have a special NDA package that will enable this CPU because it's not publicly announced. So in VTune or APS, we cannot have the public support until it's announced. So that's why you need to just to ask about this package. So Michael, I don't know if it probably can help with getting the package.
Sure.
NDA package, yeah. It's available and everything should work. Yeah. On Skylake server.
Thank you very much.
Are there any other questions? Dmitry, do you have any other quick items you'd like to cover as we're wrapping up here?
Yeah, probably I have a question to audience. If power measurements or counters are at interest or like power in terms of performance to watt and all that. So because I think that's currently through REPL interface, so we can get these counters and also characterize somehow the workload in terms of like energy, but we just don't know if if like somebody is interested in this.
So I can make a quick comment on that. I know there are people that are interested. I would say it's probably not as interesting to most of our users as the MPI performance and scaling information that you have, or the OpenMP, or the core level performance information. But there would be a subset of people that are interested and are looking at power.
So are they just try to characterize their workloads towards like power efficiency, or what's usually the interest in this? Sorry.
Yeah, I think it's typically characterizing and comparing across architectures, power efficiency. That's a big concern for us going forward to exascale because, we're become power limited in the data center, and that constrains everything. So people are looking at, both architectures and algorithms in terms of their power efficiency. And so obviously being able to quantify that can be helpful. For the majority of our users, that's probably not a primary interest, but like I said, I think there are some that are kind of more of a research, longer term research interest in that area.
Okay, yeah, thank you for the feedback. And sorry,
yeah,
who was
that's
that?
my impression as well.
That was
okay.
Yeah, that's my impression as well.
Oh, okay.
That there certainly are people interested in it. There are users, not just LCF people thinking about exascale. There are users who are thinking about it, but it is definitely people doing research in that area are more concerned than the average application person who is just looking for maximum efficiency, maximum shortest runtime.
Mm-hmm. Okay, yeah, thank you for feedback. So, that's probably all.
So I have I noticed in talking about how APS is used that the way you run it to get an overview is very similar to the idea behind Alinia's map product. And Bo, are you online, Bo? Bo Paisley from Alinea is one of our participants. I'm not sure if he's still on or not. If you're on, we can't hear you. Okay. Well, anyway.
Yes.
He is on, but we can't hear him. So I was just wondering from both of you. I don't know, Dmitry, if you're familiar with that product, but perhaps Bo might have
performance reports, right? Yeah.
Yeah. Performance reports as well as map.
As well as map. Yeah.
Yeah, I'm actually less familiar with performance reports, but I have used map. And I'm just wondering, I'm sure that there are some things that you can learn from one tool versus the other. And if either of you had any thoughts about, choosing one for some situation. So Bo is on the chat, but we can't hear him. So he's probably furiously typing. So he says he's still looking at the differences himself, but there is some overlap.
Yes, absolutely. Raymond,
Mm-hmm.
I think that we tried, to reuse the hardware performance counters expertise that we have in VTune, probably to make hardware event-based metrics more, like to do inside where it's possible to probably to inner node performance mostly, right? And yeah, actually, probably this is one of advantages. But LNA performance map, performance reports also is pretty, has pretty good and clear interface, and I think we can build analogy between performance reports and APS in some sense. But I hope that through APS we also can express the expertise on hardware counters that we have in VTune, on metrics based on hardware counters.
So Bo says in the chat that at first glance he thinks that APS is perhaps more powerful on Intel and a bit lower level.
Okay.
But he says the advertising is more focused on the higher level user. Right. So he also mentions that, as you were just saying, that APS uses the hardware counters, and performance reports uses sampling. So due to the derivation of the data, you'll get a slightly different view of what's going on.
Yeah.
Is that part is my observation.
Okay. And again, our goal is to, probably it's not currently the case, but again, so please take into account this is beta. We want APS work on any scale, on big scale. So this is our goal. With thousands of nodes. With thousands of nodes.
Yeah. So my takeaway from this is that if you're not sure where to address, where to look more closely about your performance, that APS is where you should start, and then that will point you to either VTune or Vector Advice, the network tool. I can't recall the network tool's name. Do you agree? Is that the correct approach?
Right, this is correct approach, and again, so for example, if you also can use a snapshot tool to quickly verify some changes, either environmental changes or code changes, to see quickly what progress do you have, like on particular performance aspects, if you want, just as a difference between two reports that might be pretty easy to catch. I mean, right. So that also might be one case how to use APS.